So I should start by asking, who here has, like me about a year and a half ago, has never even used Docker? Right, has been kind of curious, maybe a little intimidated by it. That's good. That's good for me to know. So you don't need to be a Docker expert. I'm not a Docker expert. I'm pretty okay with it, but you don't need to be an expert to understand this. Gonna kind of handhold you through it. So what I want to talk about is, since we can put databases in containers, how that ability makes your development and testing, it can really be a boon to make when you have changes in your models and things like that, be a lot more fluid and agile. So design changes. Things are changing and evolving constantly. I'm very happy that I get to ride a bike like this. I noticed that the wooden bike doesn't even have pedals. I have no idea how that works. So I'm glad that that kind of design changes and evolves throughout the centuries. And the same kind of thing happens with your applications. Especially during the beginnings, we're evolving it very rapidly and evolving our domain models very rapidly. But even after, if we're working agilely, even after we start deploying stuff into production, we have the ability to evolve our applications as the business domain and ideas and solutions or other problems pop up that we want to change. So when we're doing that, we can do all kinds of testing to make sure we don't have side effects as things evolve. So we can run unit tests, we can have integration tests and use mocking, and we don't even need to involve a database, an actual database while we're doing that. So you can contain all of that within your development environment and then just take everything in one single solution and post it to your source control and share it across with your team, right? You can share it with your devs. They can pick it up and just start going and have all the code and all the tests and just start running things. And your testers and everybody else involved. And you can even take that whole kit and caboodle and push it through your CI/CD pipeline. It has all the code it needs to run the apps, run the tests. It can use package managers, and it can also use Docker containers to pull down other things. For example, I use a lot of ASP.NET Core, and there's images for that. So I can fluidly grab what I need, whether I'm on my development machine or I'm pushing this into the cloud through a CI/CD pipeline. So that's pretty easy. But eventually, we really still want, if you're going to be persisting our data in a database, and as we're doing development and testing, we need to be able to see how all of that is going to truly interact with a database. So we want to do an integration test. We want to have integration tests that force things to come in and out of the database. And we want to be able to test that way. But when we're doing that and we have a database, especially like somebody like me who's using SQL Server a lot, right? When you start talking about sharing all that across your development team and through the pipeline now, especially with something like SQL Server, you have to make sure everybody's got the database engine installed on their development machines. You have to make sure they have the database. You might want to push some migrations and changes. As you evolve your model, your domain model, you also need to evolve the schema of your database, right? So getting that through all of those workflows and sharing with all of those people suddenly gets a lot harder when you're adding an actual database into the mix. And it's not just me focusing on SQL Server. If you think about, our model's changing and our database schema is evolving, people who are using NoSQL databases, document databases, things like that, it's not as much of an issue because they don't have schema, right? So you can evolve your model and then you're just storing documents that have a new shape and it's no big deal. You can store them in the database. So, but this is a pretty recent poll from a company that updates like every month. There's still a lot of relational databases out there. And even among those relational databases, Oracle, SQL Server, MySQL, they're the ones that are most heavily used. I don't foresee a future of Oracle ever being distributed in a Docker image. MySQL has been for a while, and SQL Server is now. So when we're dealing with not only sharing our code and our tests and the need to pull NuGet packages and Docker images and things like that across, we want to have an automated process that is consistent and that it's repeatable, right? Instead of saying, oh, we've got some new T-SQL files, you got to update the schema, do it however you want. Right? Open up SQL Server Management Studio, run SQL command, or some people like DBA types who have been doing it for a long time, they might do these backpack files or DACPack or something. I don't even know how to use that stuff. And that's not really like a consistent process, right? We want to have a consistent process as we say to everybody, here's the new stuff, just use it. And they don't have to worry about that extra layer of installing a database engine or updating the schema of the database files, things like that. So with my focus on SQL Server, my really big introduction to Docker finally was the fact that SQL Server for Linux came out and that Microsoft was creating a Docker image for that. So that was my path, but there are other databases, relational databases, again, probably not Oracle anytime soon, but there are other databases, RDBMS, that are in containers. So Microsoft has created public Docker images, and there's just some links where you can learn more about SQL Server for Linux, which is the same SQL Server as SQL Server on Windows and Developer Edition, et cetera. And the Docker image, although there's a path through the Docker Hub, Microsoft actually stores all of its images in its own repository. So the MCR is its own repository. And for those of you who are using SQL Server, now I'm using SQL Server for Linux, but just as an FYI, there are also Windows containers versions of the regular, the Windows version of SQL Server. Those are available. But by having SQL Server, and I don't mean your database, I mean the whole SQL Server engine in an image that you can run in pull the image down from Microsoft repository or your own company's repository or the repository on your machine where you have Docker, your development machine, your testing machine. It becomes just another component in your application. It's not this other thing. It's not this big engine that you have to install. Who's ever gone through a SQL Server installation, SQL Server engine? It's not fun. And I'm a developer. I'm like, I don't have patience for any of that stuff. So having SQL Server be available in a container that I can just run, and that like installs, it doesn't install SQL Server on my computer, it's just SQL Server engine is now running in the container, it's a revelation for me to be able to do that. So a lot of people might wonder, okay, yeah, but you're talking about a database in a container, right? Now, database in containers in production is still going to make a lot of people nervous. And one of the things that some friends on the SQL Server team said is, we used to have the same issue with virtual machines, thinking about SQL Server and virtual machines 8 years ago, right? So eventually, I think more people will be more comfortable with doing that, with having your database engine and persisting your database in containers. And as a matter of fact, Kubernetes has all kinds of support now for SQL Server for if something goes down, they just automatically can spin up another node of SQL Server. And so that's a path. But I'm not working here focused on production. I'm more focused on dev and test. And for dev and test, this is where, for me, the ability to have SQL Server in a container really, really shines. First of all, the container, SQL Server engine is isolated, right? So it just uses the resources, Docker's resources, that you've allocated from your machine to Docker. It only uses their resources. And you can actually run a number of containers, many instances of SQL Server engine or your database engine on the same machine, different versions. Pinal Dave was running, today if you were in his talk, he was running SQL Server 2017 or 2016 on his computer, but then he wanted to demo something with SQL Server 2019. He actually spun that up in a Docker container on the fly. Nobody really knew that. I mean, he said something about starting up Docker. He started up Docker and started up the database, and it was just right there. So having them be isolated is really awesome. It also, again, is really consistent. So not only can you start up the engine, but you can also share configuration and T-SQL that you want to get run, or your DBA wants to be sure is run on each of these databases as they're spun up. It's portable. You know, anywhere that Docker can run, anywhere that, Docker for Linux runs on a lot of different environments. Docker Windows containers only run on Windows. But anywhere that you can run Docker, you can now run this SQL Server. I'm using a Mac. I'm not using Parallels, right, or Boot Camp or anything. I'm just directly in Mac OS, so I can run that there. And it just starts up really easily, and you're not doing an installation. The image that you use, it's already installed on the image. All you're doing is starting it up and it'll run some SQL scripts that are doing it. So I want to just show you what that looks like just at the command line, just so you have an understanding of what I'm doing. Then I'm going to move over to using it in an application and some testing. So to run it, I already have pulled the image. The image lives on my machine. We don't need to wait for that. Don't have that much time. So in order to run it, it does require that you pass in some environment variables, accept EULA, and pass in a password. You define two different ports. One is the first number is the port that's exposed on your machine. So my host machine's port 1600 is where I'm going to be able to use a connection string and point to and access the database that's running in the container. Inside the container, it's exposed through port 1433. And then I'm just identifying what image I want this container to be run on. So I will just do that here in the command line. So this is the same as I just showed you, and I'll run it. The container is now running. Now SQL Server still has a little bit more to do, so I'm going to go over to Kitematic. And you can see it's running scripts. So there's a file inside the image that says, okay, as soon as you run this script, it's creating master files and things like that. So that's the default. That's not my code. It's just the default. So now you have a proper thing. And now it's done. So that was like 25 seconds total. I have SQL Server, full brand new engine that wasn't running before on this computer, running in a container on Mac OS, and it's ready to roll. And I'm going to flip over to Azure Data Studio, which is an Electron-based. It's actually started its life inside of Visual Studio Code, but now it's its own application. And I'm just going to refresh this connection. Oh, wait, no. I've got this one running on 1600, haven't I? So I'll just start a new one. And that should be all set with the password. Right, and there's the database. So now the database is running inside of my container, but because I've exposed it outside of the container on my own port 1600, I can now interact with it and just work with it, as I would work with anything else. I can use SQL Server Management Studio. I can use an application that knows the connection string to do that work. So that's all I wanted to show you there. And I will have got enough things running, so I'm going to close that one down. Hello? Hello? It's always... it was not there. Thank you. You don't have to get closer, but thank you for being right there. So now I'm going to move from using this at the command line to now focusing on my application. And it's just a really simple application. There's no need for a complex domain here in order to show you the things that I want to show you about how all this integration works. So I have a little web API. It's got two classes. One is called Agilista, and it's got an ID, it's got a name, and the primary focus of that Agilist, and their Twitter handle. And then the other class is called category, and it has an ID and a description. I have some controllers. I have a values controller, which just exposes strings. I like to have that in there when I'm just testing, because if something isn't working in my real controller that's also dependent on the database, I can just go back and just make sure the simple controller that doesn't care about anything else, if it's working, then I know the API is running, and so I have a better way of figuring out what's going on. So that's what that one is for. And then I have another controller that has a bunch of basic HTTP methods, but the one I'm just going to work with reads from the database, queries the database, and just shows a list of the results from the database. I also have some tests. There's unit tests that have basic logic to just test my domain models to make sure the logic in there is working. I create a new one, make sure the ID is populated with a GUID. But I also have integration tests that hit the controllers. So one of those just makes sure that the controller, like the values controller, is returning the string it should be returning. Here's the values controller. So one of them checks to make sure. That's not the test, though, so that's the controller. There's a lot of code in here. I'm going to expand the tests and go to the integration tests. So this first test just makes sure, verifies that I'm getting JSON back, right? Just a simple test, so it's not complicated, and it's only the values controller, so it doesn't involve the database. The second one just makes sure that I'm getting the strings back I expect. So again, this is a simpler test than the one that is dependent on the database. The third one hits the Agilista's database, which is going to hit the data, not just the controller, but the actual database, right? I don't want to do mocking here. I'm trying to make sure things are working correctly with the database, that my Docker container is spun up correctly, that the Docker container got a real database, and the test data, seed data is in there, et cetera. So that just verifies not only is the controller working, but it's sending me back some of the seed data that I anticipated. So in my development environment, if I have the database already running, I could just run this locally. I don't have to involve a container, but I'm just going to skip that part. Like, I do some testing to make sure things are working before I add a level of complexity and get everything and get my API inside of a container, right? Just make sure if something's wrong, I know which levels are working and everything. But I'm going to skip to running this stuff in containers. And in order to do that, I want to make sure, especially for the people who have never used Docker before, that you at least have a little lightweight understanding of what we're going to be looking at. Every Docker image that you want to create needs to have something called a Docker file. Inside a Docker file is instructions for building the image. Okay, so that's called a Docker file. It doesn't have an extension. Then we also have this tool called Docker Compose. Docker Compose lets you orchestrate a number of containers together, okay? So that's what I want to be able to do. I want my API in a container. I'm going to have a SQL Server database in a container. And I have one other container I'm going to be running, which is going to make sure that my SQL Server database engine gets my new database and gets the schema of the database, right? It's got my T-SQL to do that. I'm going to be feeding T-SQL and some seed data. So those are three different things that are being orchestrated to run all together with dependencies on each other by the Docker Compose file. So I have two pairs of these, Docker file and Docker Compose. One is to spin up the web API and let it run for me. So I'm going to do that first. So I have a file called Docker Compose. That's a YAML file. YAML is a syntax that has very, very specific formatting, but then because of the specific formatting, we don't have excess in there, quotes and XML or anything like that, no angle brackets. So that's the compose file that's made up of the three sections, right? It's going to spin up my API, it's going to spin up my database container, and it's going to spin up the migrations. And I'll talk about the migrations a little more in a minute. But I actually want to skip ahead here to show you visually what's going to be happening before I run it. So because of the Docker Compose, the first thing, the way it's structured, the first thing that's going to happen is the database container is going to spin up, okay? Then another container that is going to run migrations, that's going to spin up, and that's going to send, it's going to run SQL, and it's going to be pointing to my database in the container and push the schema information and insert the seed data in there. When it's done, it's just going to disappear because it's finished doing its job. I don't need to use resources anymore. And it does that automatically. Docker will do that because it's finished doing its job. It's completed its task. When that's done, the next thing that will happen is my third container will get spun up, which is based on an image that's built from my web API code. Okay? And that's also doing things like it has a dependency on ASP.NET Core. So it's pulling that image down from Docker Hub, right? Some other things. I've already pulled all those images, so we don't have to wait for any of that to happen. And once that spins up, it's talking to the database inside the other container because I'm passing the SQL, the connection string around, and then I can run some application against it. So I'm just going to right-click on the Docker Compose YML file, and I'm going to choose Compose Up. Visual Studio has a great extension for Docker that lets me do all these kinds of things. So it's spun up the different containers, and I can see the status of the containers. This is my migration container, the flyaway one. That's the one that's updating the database in the database container, and I'm waiting for that to be finished. Remember, when it's done with its job, it will disappear. Sometimes on my little wimpy MacBook, it takes a little longer. But it's done now. So now I know the data's in there, the database is ready to go, and I can go and run this. Now, I also should point out that I'm exposing my web API through my computer on port 81. So I can just browse to it directly from there. So I'll do localhost 81. First thing I want to do always is make sure it's running. Okay, it's running. That just kind of verifies it for me. No, I don't like that. I need to get to here. And so now I'll also go against the database. Of course this always happens. Okay, let's see if this is running. Refresh, database, refresh. I know I didn't do anything wrong. So, pardon me? I didn't understand what you said. No, mine is on 16. This is on 1620. That's annoying. Let me just run it again. This usually happens the first time I go and make sure my demos are working right before my talk, and then it's like, oh my God, it's not working. What did I do wrong? And then I run it again, and then it's working. Okay, I'm just going to take these down. Remove all the containers. And I'm looking around quickly, like I'm in the right, all the right places. Come on, come on. So I know the database was there. There it is. Second time's the charm. That only happens when you have a small amount of time, right? So there's the database that got populated, and now I can flip over to here, and there comes the data. Yay! Okay, so I can interact with that database. For example, I'll go back over here and edit some data. just do this one. Go back over to Chrome and refresh. And there's the change. So I'm definitely running against that database that's inside the container. So Docker Compose pulled all of those things up, which is really nice. But the real the next thing I want to do is for testing, right? So that's like development. Okay, now I still have to manually be involved in that test. So now what I want to do, I could take all of these down and start. Now I have my second YAML file. The second YAML file, these parts of it are exactly the same. I've got my database service, and I've got my migration service. But I also now have a project for doing unit tests. So it works just the same. I get my container, my database container started. The migrations container will start up and affect the database and put everything in there that I need in there. That will go away. And then my test container will start up. It'll run all the tests, but there's a big difference between this and my API. My API is sitting there waiting for me to work with it. But the tests, when they're done, I don't need the container anymore. So the container goes away. So let me run that. Now I can, this should be fine this time. Tempting fate, right? I'm going to remove all the containers again. So you can see that this compose file is going to make this happen all over again, spinning up the database and everything. But there's a difference between how I ran the API and how I'm running the tests. And I got stuck on this for 10 hours because the tests weren't working. I was messing around with the Docker file. I was messing around with the Docker Compose file. I learned so many things when I was trying to figure out what was going wrong. So that's a really, really good benefit. And so hopefully I'll save you some time. But here was the problem. I was using this parameter, this -d parameter, which in Docker run means run it interactively. And the test can't be interactive. I need the test to go ahead and run and get everything done and shut down. So that was the big difference. So I'm going to go ahead and run test. So I'm spinning it up. Here come the containers. There's the migration container, the unit test container. The migration container is still doing its migrations. Another thing, because I'm not running this interactively, we're seeing all of the logging. And you can see some of the logging is coming from the Flyway migration container. Right? Some of the logging was coming from the API container before when it was spinning up. And now my unit tests are running, starting them. And remember, one of those unit tests runs against the database. So the database has to be ready with data in it, ready to go. And all of my tests passed. So that all worked, right? So here's the beauty of this setup. It's time to evolve our model, right? Somebody says, hey, we've been tracking the person's primary focus, but all these people doing Agile, they have lots of different expertises. So we also want to track a secondary focus. So we've got to change the model. We've got to change the controller so it knows to expose that. We need to change the database schema. And also for tests, for the CRUD testing, we want to also change some of the seed data. So that's all fine and good, except now, in a normal situation, we'd be like, oh no, we got to get the schema changes to the database across to everybody. We've got to make sure the schema changes are in our pipeline for when we're testing, doing our DevOps testing and things like that. Right? So normally that's, oh, you send the SQL and everybody does it differently. We don't have this consistent way. But now because of containers, right, instead of going, oh my God, how am I going to deal with this? The containers are all set up, and they know how to deal with that. So I do want to flip back to making sure you know what's going on with migrations. Boop, 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 boop. Okay, so there's a lot of ways to get your database and seed data into a database, right? I'm using Flyway, which is a migrations tool that works with all kinds of relational databases. And it is able to track which migrations, in other words, which SQL file has been applied to the database. That's if you're persisting, like you can persist the data in a separate volume, separate from your SQL Server Engine container. So it can keep track of that. In my case, it's always going to be fresh, so it's going to see, this is a brand new database. I don't have any tracking history yet, and I'm going to just go ahead and run all of them at once. So that's the one I'm going to use. If you're doing something like load testing, you probably don't want to do this because, if you want to get like 2 million files or 2 million records in a bunch of data tables into your database to do load testing, you don't want to do that by running a lot of scripts. So there's other mechanisms to do it. You can even create another image that has this database in it and spin up that container, pull in that database, right? There's all kinds of things you can do. But I'm using this migration tool, Flyway. And I'm going to flip over to a different branch. The difference with this branch is now I've made the changes I listed that I would have to make. So for example, in my API, my domain model for Agilista has these new properties, right? Secondary focus, so there's an ID, so it's easier to update if I want to and don't want to have to deal with the whole object, or I've got the object, so I can query objects back easily. So I've made that change in my model. I've created the SQL to affect the database. So here's my Flyway container. I needed you to see what it did, like see it in action before I opened it up and showed it to you. So the Flyway container starts with Flyway's image, right? It pulls that image down, and then it builds a new image, starting with that image, copies in whatever files I have in my Flyway folder, and two of those files are, wait a minute, this needs to be refreshed. Okay, because I'm like, there should be 3 files now because I have a new file. I've added a new file. So this file was already there. That just does some initialization and creates some users and creates some tables. The second one was what fed my seed data in. So now that I've made the change, I've got another SQL file, and it alters the Agilista's table. It adds in that new foreign key property, that foreign key column, the secondary focus ID. It updates, I'm giving it a little more seed data so that when my seed data will now also have secondary ID in there. And I'm even creating an index, right? So it's just additional SQL. So Flyway is going to run all 3 of those this time. Okay? And again, if I was doing persistence, Flyway might see, the init and v1 and v11, they were already run. We don't have to run that. So it's idempotent if you're using it in that way. But for dev and test, I'm starting with a completely fresh database each time. So that's not an issue. It's just going to run all 3 of them. And then I have made a change to the controller to also expose this new information. And then the other thing is I've added one more test, one more integration test. And this new integration test also checks for this secondary focus. Okay, so now I have 9 tests with 2 of them dependent on the actual database. One of those is dependent on the new schema changes that I've made, right? It wouldn't work otherwise if the schema change hadn't been applied to the database. So I better remove all these containers so that you don't think I'm playing any tricks on you. And then I'm going to go ahead and run the tests again. And watch this space here, right? The containers are spinning up. Flyway is still busy doing its job. And again, because we're running not in interactive mode, we can see the logs of what's happening. So there's Flyway migration, starting up the database. It did everything it needed to do. Now the unit tests are running. I'm crossing my fingers. I didn't cross my fingers soon enough. I'm hoping that whatever just did that weird thing was the same stupidity that happened the first time, and I'm just going to run it again. Because I wouldn't be here if that wasn't supposed to be working. That's my story. Now it's going through all of that again, but this time I didn't delete the database first, so it's going to do some of that stuff a little more quickly. Like, don't do that to me. It's like a bad kid. So the fact that all those tests passed means that that second test that's dependent on that migration happening really worked. So I can start completely from scratch and send this, put this in source control, right? And everybody can go grab it, and they've got the database changes. Or let's imagine we finally decided, okay, SQL Server 2019's been out long enough, right? We want everybody to switch to SQL Server 2019. And they can get it because I can just change my image to be the image that's being used here and being referenced in the Docker Compose. I can change it to point to that image, the 2019 image, instead of the 2017 image. And then everybody who's running Docker Compose is just going to get that image and that database and any new capabilities that we want to be taking advantage of, which is pretty sweet. So there's one last thing I want to show you, which is about when it's time to deploy to your CI/CD pipeline. Now I have to get all the way back here. Yes, and we're happy again. OK, so I just want to talk a little bit about pipelines. I know there's a lot of DevOps experts here. I'm not a DevOps expert, but I know enough to have been working with this part a little bit to see this happening. So how I've got this set up. First of all, I happen to be using Azure pipelines, so that was my first pipeline that I learned how to use. And I've got my pipeline tied to my GitHub repository, all right? So anytime I do I push up to the repository, it really depends on how the pipeline's set up. So let me show you my pipeline. Maybe I'll also show you my repository. There. Oh, no, I'm not going to do 2FA. So I have a repository. My repository has 3 branches in it. The 2 that I showed you, like test 1 and test 2, or whatever they were called. But I also have a repository that is like, OK, deploy my, I merge in, and that's kind of my master test, right? So I do pull requests on that. So my pipeline is set up such that don't want the logs. Let's go over to the pipeline. Actually, the pipeline is defined in my project. So I pass that along also. That's defined in my code. That goes to GitHub. And then Azure Pipeline is, I've told it, read this file, this YAML file, which is, here's the one for test. And there's a lot of moving parts in this. But once they're all set up, it just works so nicely. So I've said the trigger to go ahead and build and run this pipeline is my branch called test master, okay? What happens is, and I'm not going to do it because the way I've set it up, it's rebuilding a whole Linux virtual machine and putting all the containers in it and in order to do the test. So that takes a few minutes. There's more efficient ways to set it up, but that was the first thing that I learned how to do. So what happens is anytime I make a pull request from one of these other branches into the master test, it triggers this. So it's not when I merge them, it's when I say I would like to merge them, it will trigger this, and it will go ahead and build up the containers and do all the same things you saw happening in Visual Studio Code. It will do it here. And I won't expand each of these, but you can see here it's building all the containers in the test compose file. Then it's starting up the SQL Server, and you can, the output of the logs from starting up the SQL Server container. Then apply schema migrations. This is when Flyway migration container is getting spun up and pushes everything into the SQL Server database. And then the last one is it runs the tests. So now it's got the API or the test container created, and then it knows the connection string into the database container, and it's able to run the unit tests. And this is a lot of debugging output from ASP.NET Core. But what's important here, you can't highlight this stuff, but you can expand it. You can see right at the bottom there, the tests ran, right? 9 tests ran and 9 tests passed. So I was able to take this just from pushing pushing this stuff up to GitHub, doing a pull request on my test master. That triggered the build pipeline. It ran everything and said, yep, up here in the cloud, everything's working as it should be. The database got started, right? The controllers are there. The controllers are getting back the data that they expect to be getting, and it's all working. And having set up all of those pieces, and there was a lot of learning involved in that, right? Obviously, in 45 minutes, I can't make you experts, but you've seen kind of all the pieces that go into it, right? But with the Docker Compose orchestration, and then combining that with the build pipeline, right? All of that stuff just goes together, and anytime I'm making changes, I just push things to source. Everybody on the team can grab it. They can do what they need to do. They can do pull requests, and and it all flows. But we don't have to worry about the database engine anymore, or changing the schema of the database as forcing everybody else to deal with those database schema changes. It just flows just like anything else, any other component that I've added in my application. I just want to point out a few other things if you haven't done pipelines before, right? My workflow was this top pipeline, right? I did a pull request to test master, and it runs my integration tests. It runs the Docker Compose test, and then it's using Flyway to see just a little bit of data so I can do some CRUD testing. But you can also have the same branch triggering other builds. Or you can have other branches, like the master, right, that triggers another build. Maybe this is the one that's actually going to be going to production. You might then have your SQL Server containers pushed out to Kubernetes. Or you might say, we're not ready to use containers in production yet, so we've just changed the production compose file. We've just got a different connection string. We're not using a database container in production. We're just pointing to, for example, an Azure SQL database. It's just using a different connection string. So that was what I wanted to show you, like just kind of this big picture about how we can compose all of these different things to take away the pain of dealing with schema changes to the database while you're doing your fluid production and evolving your model and being able to have the database be as agile as all the rest of your software while you're developing it. So that is my story. I think we have a few minutes for questions, if there are questions. Okay, we have time for one. My GitHub repo is at Julie Lerman, just my name, same as my Twitter handle. And all this stuff, I'm going to put the PowerPoint up there along with the rest of the code.
Big round of applause for Julie.
Thank you.
Julie, your one question will be, what kind of test do you run against the database container?
I'm using XUnit because I'm developing in ASP.NET Core, so I'm using XUnit. That was so fast, do we have time for another one?
Go on then. What is the point running unit tests in a Docker container if you can run them on your local machine or CI pipeline? This one's harder.
Well, no, it's just everything's self-contained. I don't have to. Oh, the unit tests. There's no point in running the unit tests in a container. I've just kept them in there, right? I was really focused on the integration test being in the container, but I was just building up that knowledge. Okay, I start with unit tests, those are easy to deal with, and then I added in the integration test. So it's really the integration test that makes sense in the container in that scenario.
Wonderful.
Thank you.
Thank you so much,
just
Julie.
Look at the other ones. It's just for myself.
What we will do, Julie, is that person there, hi, works at Slido, and she can get you all those questions so you can put them up online with all your other stuff.
Thank you so much. And for the few people who are like, oh, really not so sure about Docker, do you have a little better idea of Docker? Now I hope
They're
have an
nodding.
aha moment.
They're nodding.
Anyway,
That's,
great.
that's pretty much as positive reinforcement as
Excellent.
you'll get from them.
All right. Yeah, it's the end of the day. All
Thanks.
right. Thank you very much.
Thanks, Julie.